highlights and goes over how to relate ratios to fractions. So as we kind of already discussed this already, but ratios are basically just fractions in disguise. We have something in the ratio of 5, 6 to 7. What that really means is we have some amount. Let's call it x, and of that we have some parts. In this case, we have 5 plus 6 plus 7, which is 18. We have 18 parts. And that total amount of parts constitutes x, and there are 18 equal parts. And of those, 5 go to one person, 6 go to another person, and 7 go to another person. All that really means is we just have 5 over 18. We have 6 over 18 and 7 over 18, each that come from here. Yeah, that's all that really means. Out of 18 parts, you have 5. Out of 6, you have 18. Out of 7, you have 18. That's really just fractions of some amount x, which is our total amount. So really, we want to say that Rob ends the game. So Rob is this first 5 over 18 fraction. So now we would have to just assess the fractions for the second part. Again, now they're in the ratio 7 to 9 to 8. Again, we add these all up together. What do we get? We just get 24. And now we just have to think about the fraction relation. So again, we have 7 over 24, 9 over 24, and 8 over 24. So now we've got our two fractions. We've got 5 over 18 and 7 over 24. Now we've got 5 over 18 and 7 over 24. So now we just have to compare these. So the easiest way to do this would just be to find a common denominator. I think the easiest way would just be maybe thinking through some early values. So 24 goes up to 48. And that's not really helpful, it doesn't really divide into 18. Multiply by 3, we go up to 72, and if we check, yep, 72 actually does divide. So now we have to figure out what to change these by. So we had to multiply 24 by 3 to get 78, so this would go up to 21. So this goes to 21 over 72, basically this one. And the 5, or in this case the 18, we had to change 4 times, so 4 18s go into that. So here we just multiply this by 4, so really what we just get is 20 over 72. Now comparing these, this one's 21 over 72, this one's 20 over 72, pretty easy to see that 21 is bigger than 20, thus 7 over 24 is the bigger fraction. And since 724 was after they started playing, we can conclude that indeed Rob does end the game with more counters than he began with. It focuses a lot more on making sure you are very good with division and multiplication and knowing when to divide and multiply. So, and also not getting caught up in all the numbers. Here you change 800 British pound Thai baht, 1 pound to 49 and 22 Thai baht. So I think this part's fairly understandable. You have 800, and for each one of those 800, you get 49.22. This is just the exact definition of what multiplication is. And if you do the sums, you basically get this number 3,9,376 of the Thai baht. And now you need to calculate, bring it back into pounds. So here you have to decide what exactly you're doing. 1 pound gives you 60.05 baht. So what would you have to do? What would you have to do to the number you calculate? This is the first number even relevant. If you decided that dividing it by the new value for the Thai baht, you'd be correct. What this really tells you is how many times this goes into that, since each one of these is responsible for 1 pound. And this basically just gives you the amount that you're looking for. And this gives you about 655.720. It says to the nearest pound, how much did he lose? So I think the best thing to do first would be to just do this number minus this number with all the decimal places, and right at the end, then you can convert it to the nearest pound. We'll just do the original number minus the number you calculated. So in this case, you have to realize that you're not taking away this number because this is the amount in Thai baht. Instead, you have to calculate your original number of pounds that you started off with, which is 800. So you take your 800, you have your new value that you have, the amount you started off with, and that's the amount you lost is just subtracting one from the other. So you do that sum, you basically just get your answer, which is around 114. So 144.27, and obviously to the nearest pound, this number is less than 5, so you just have 144 pounds as the approximate amount that you have lost. And that's pretty much it for this question. This question actually incorporates a lot of elements, from understanding exponentials to percentages to also a bit of graph sketching at the end. To start off with, and as well as obviously sequences. So we start off with 1,000 bacteria, and every day it grows at 50% of the total amount. So what does that really mean? We've kind of encountered this before and kind of gone through how to represent percentages, but give a quick think about how you would represent an exponential growth of 50% per day in terms of a formula. That's more important for the next question, but for this one, it's important to kind of get an idea of what's happening. Think about the first few values. You start with 1,000. The 50% means you add on 50% of whatever's here. 50% of this is obviously 500. You add that on, you end up just getting 1,500. If you think about the day after that, you're getting on 50% of this. So half of this, 750, added onto this, which is just 2,250. So every time you're adding 50% of whatever's there, which in terms of percentages we've already discussed, is the same as what? Is the same as multiplying by 1.5? Maybe 1.15? Is it dividing by 0.5? Which one? There's the first one. Yeah, you'd be correct. Just multiplying by 1.5 each time. All that means is 1 and a half, kind of adding that together. That's what this represents. Is what takes you from step to step. So obviously a geometric sequence is that where you have some numbers, and between each number, x1, x2, x3, hopping to each number, you multiply by the same value. You multiply by the same value, a, for example. A each time. In this case, a is equal to 1.5. So yeah, that's basically what it is. A geometric progression since you're multiplying by 1.5 each time. The next one asks you for a specific value. So here you have to kind of consider the formula of the progression. So obviously we thought we start off with 1,000. And we've narrowed down that 1.5 seems to be the multiplying factor. So now we have to think about what we do next. Is it 1.5n? Is it n 1.5 to the n? Or is it something a bit different? Give that a think. If you thought it was either of these two, you're almost correct. But in terms of the problem statement, really we're thinking about n minus 1 here. Because if you think about on day 1, this would be equal to 1. If we just thought about to the n without the minus 1, we just forgot about this. If we think about the first day, n would be equal to 1, we'd have 1,000 times 1.5, which would be 1,500. That's on day 1. On day 1, we actually just want 1,000. So on day 2, this would be 1,000. Then with n, again, we'd be thinking a day ahead almost. We're doing n minus 1, that just means on the first day, this is equal to 0, so we can this is just equal to 1, so it's 1,000. And on day 2, which is when we want the first rise, we would end up having 1.5 to the 1, which would just give us 1,500. So really, that's our formula. So, and now with this formula, what would we do? We have the 10th day and the 6th day, and k times the population. So what that really means is that 1,000 times 1.5, I guess, to the 10th day, which in this case correlates to 9, n minus 1, is equal to k times 1,000 times 1.5 to the 9 to the 5, so obviously 6 minus 1. So to find k, all you have to do is just do a simple division. So 1,000 times 1.5 to the 9 over 1,000 times 1.5 to the 5, and just type that in. What do you get? And if you got 5 then a bunch of numbers, so 5.0625, you'd be correct. I think here it wouldn't hurt to just write down everything since it's only a few numbers afterwards. It doesn't go on for too long. Also, they didn't really specify. So just noting that down, 625 shouldn't hurt too much. And now we have to think about graphs. So it's useful to think about the behavior exponentials. As n gets big, this expression gets very big. Obviously, with each number you're taking 50%, but as the number grows, that 50% keeps getting larger and larger and larger. So I guess you've already learned about exponential graphs, but overall, if we set out some axes, this is overall how we'd expect it to go. So we have to sketch A and B. So B is basically the same as A, except it's 30% per day. So what that really means is that instead of 1.5, it's 1000 times 1.3 to the n minus 1, which just means it's a slightly smaller increase. It's still exponential. So here we have to consider first A. We can maybe do A in red. So A would just be a standard exponential, and you just go and then obviously shoot up to quite a high amount. We can label this A. And obviously starts at 1000 because that's the base value. B, basically the same, except it's going to be a little bit less steep because obviously our increase is a bit smaller. So B will kind of shoot off a lot more slowly. B. So it's a bit rough, but you kind of get the idea. It's a bit of a less steep curve. And that's how you can compare them to tell that B is obviously a little bit of a smaller change. This next question basically sums up the idea of fractions and ratios pretty easily and pretty quickly in a less concise question, and relates a bit to geometry. So here we're considering a triangle with angles in the ratio 1, 2, 3. So again, as I mentioned before, when you have something in the ratio 1, 2, 3, that just means you have some amount of pieces. In this case, is always the sum of the ratio. So in this case, it's 6. You have 6 pieces of some value, which in this case is the angles in a triangle, which obviously we know is 180 degrees. There are 6 pieces of the 180, 6 equal pieces, and the distribution is as follows. So if we were to distribute these angles, we'd find out that each piece is 180 over 6, which is just 30 degrees. So that means we have one 30 degree angle, one 60 degree angle, and one 90 degree angle, which obviously we have a 90 degree angle. Thus, we have a right angle triangle because 90 obviously right angle triangle. Next question basically is just what we've done before, thinking about percentages over time, but just one of the parts of the question relies on you have to solve the previous parts. You have to make sure you don't get it wrong. Draw about this part, avoid some distractions. So you started off with 400 sandwiches in May. So the next part is quite easy, 20% more sandwiches than May in June. So we've already covered most. We're multiplying it by the percent. So we're multiplying in this case by 1.2. If you're not exactly sure where this comes from, maybe have a look at the previous questions to kind of get intuition, but I feel like at this point we've established that. 1.2, and that would give you the amount of sandwiches that you sold in May. So that you sold in June. If you do the sum, you basically get that you sold 480 sandwiches. That's the amount you sold in June. So in July, you sold 15 fewer sandwiches than in June. So we went over in a previous question, I think in relation to the pressure, about how fuel works. If you remember, we have you can think of it as 100%. We take away 15%, and we're just left with 85%. And that in terms of a fraction is just 0.85. So we have a 480, and then we have our percentage change, which is times 0.85. And if we do the sum, we get 408. So 408 is the amount of sandwiches we sold in July. The change from our sales in May to July. So basically, for this, what you need to do is just have both of the numbers and think about the number change and relate it to percentage. So we had 400 in May and 408 in July. So the difference is 8. So from May to July, percentage change means in terms of May. So realistically this would just be 8 over 400, because that's the amount we had in May. And if you do the sum, you get 0.02. That's as like a fraction. Obviously, if one that's a percentage, we have to multiply that by 100. So that just gives us 2%. So yeah, we had a 2% percentage change in the percentages that we saw. Here, this is actually start of two quite difficult extension questions related to the topic. So these are more in the kind of 9/ even upper 9 grade. Let's say actually around the 9 grade. So if you're thinking around that level, you find most of these questions quite easy. These might be some extension questions to consider. So, and they kind of test your knowledge in considering ratio and proportion. So it says in September the ratio of boys to girls in school was 3/2. So I guess using our past knowledge of ratio and proportion, again we can think of this as a fraction. We can denote as x to be the amount of students in the whole school. So whole school, I guess a better way to represent, we can just call it total students. Total students. That's x. And obviously 3 over 5, 3 over 3 plus 2x is the amount of boys. And 2 over 5x is the girls. So now it tells us by June there were 50 fewer boys, 20 fewer girls, and the ratio of the boys to girls was 7/5. So the fraction part is okay, but if I was to think about, so this is the actual amount. This is the amount. 3/5 x is the amount. So 80 fewer literally just does mean that we have 3/5 x minus 80. That's the actual amount. And same for the girls, where it would just be that minus 20. But I think we can just focus on the boys, that there should be enough to solve the problem. So we have to think about, what is this equal to? Is this just equal to whatever the amount was before, which was the total amount? So there's, something along the lines of, like, how does this relate to the total student body? So before we pretty much said, so now we have a new ratio, 7/5. So would this just be equal to, as we've done before, 7/12? Obviously 7 over 7 plus 5x. Is that all there is to it? This could be one option. Could it maybe be, since we've lost 100 students, 7/12 x minus 100? Or is it maybe something different? Give it a quick little think. If you thought it was neither of these, you'd be correct. So actually what it is 7/12. That stays about consistent, but it's not of x. X, again, we mentioned, was the total amount of students. So you have to think about the total student body. We've lost 80 boys and 20 girls, which in total is a loss of 100 students. So it is 7/12 of x minus 100, because that's the total amount of students we've lost. X minus 100 is the total amount of students we have now, and 7/12 is the ratio we have of that. So really, all we need to do now is just solve this equation. So we can just expand 7/12 x minus, and obviously now we just need to do, just expanding. So just multiply 7/12 by 100. If you do that, you basically get 175 over 3. I think it might be easier to just keep things in fraction form for now, because decimals, they seem to be quite long, instead of just storing it as, just a few dp, which uses fractions. So now, I guess there are multiple ways of doing this, but the way I do it is you just take away this amount from both sides, so as in just move over the x's to one side. So we just do 3/5 minus 7/12, that will basically give us 1/60th. So we take this amount away from both sides, and we're basically left with 1/60th x minus 80 is equal to minus 175 over 3. So now, I guess, to cancel out this, we could just add 80 to both sides. So if we do, just plug it out here, it's minus 175 over 3, and multiply that, add that to 80, which is the amount I'm giving, we get 65 over 3. I think it's 1/60th x is equal to 65 over 3. So we're basically solving for x, because x is the total amount of students in September. Obviously, if we just found this number, which is the amount in September, and minus 100, we could find the amount in June as well. So here we have to do is basically just that x is equal to this divided by that. highlight this divided by the blue. So if you just do that on your calculators, you would get 1,300 hopefully. And yep, that's the answer. X is 1,300. So the amount of students in total at the beginning of September is 1,300. I think the best way to start would be to just set up a diagram to understand kind of what's going on. We can represent the two cities as A and B, and now it's time to kind of trace out the journeys. So I'll represent the path of train 1 in red and train 2 is blue. So train 1 started from A and went to B, and it traveled, some distance. And that maybe took some amount, let's say k hours. In that same time, k hours, a train from B also managed to travel, some distance, and at that point they met. So we're saying that they met at, at k time, k hours, they met. And then the first train, it got to that point, which we can represent maybe with this line. It got to that point, and it had to travel pretty much 9 more hours. So you just represent that as the second part, and that took 9 hours. So, and this second train got to that point and then traveled 4 hours. So what's really happening here? This train traveled the distance that train A traveled in 9 hours in time k, and this train traveled the distance k in the time it took the other one to do it for 4 hours. So really there's two ratios going on here, 4 to k and k to 9. You're going to want to get an idea of where these come from. So the speed, almost, you can kind of think of as like the ratio of one speed to another as being 4 over k, and the other one being k over 9. So pretty much what's happening here is this is traveled in 4 hours and this is traveled in k hours. So kind of, let's say k was 8 hours, then 4 over k would mean that this one traveled, that, A traveled at a speed that was half of that of B. And that makes sense, I think, because obviously that's 8, 4 over 8 is equal to a half. So these kind of relate how the speeds correlate to each other. Same with this one, k over 9, so how fast B is traveled in relation to that. So if, let's say, k was 18 hours, then this would be 18 over 9, which is 2. So that basically means that train A was twice as fast. So we're doing this all in terms of train A. So pretty much these are the two ratios we have, and now if we just cross multiply, we can get a relationship between them. The 36 is equal to k squared. And what that really tells us is that k is equal to 6. So now how did each train travel altogether? Well, if k is 6, then we have some pretty simple maths. One is 6 plus 9, 6 plus 9, which is equal to 15 hours. The second one is k plus 4, which in this case is 6, so 6 plus 4, which is just 10 hours. So hopefully that makes sense.